Oh, so we go up first.
Math or
Well, I have
gotta get to the accuracy.
we go up flat.
I mean, yeah, it was not.
Yeah. I got a 96 out of 1.
7 days.
Those are cool.
On the 69th day.
Oh, I did want to mention for the exam, I rounded everybody's grade up to the nearest half point, which actually made a big difference for some people. Like it bumped them up a letter grade. Right, so the average ended up being like an 84 or something like that, which is really good for a semester exam. Right, so you guys did a nice job on that. What did you guys think of doing it on Edge Elastic? Not too bad, it's fine. Okay, so I tried to make it as similar to the air test as possible. Okay, so that's what you can expect for the air test at the end of the year. Today, we're going to start talking about rectangles. So we had been talking about parallelograms. It's been a little while, so hopefully we can get back in the swing of things and remember these properties of parallelograms as we start to talk about special parallelograms. Okay, the first one we're going to look at today is a rectangle. So a rectangle is just a quadrilateral that has 4 right angles. Right? The properties of a rectangle include all 5 properties that we talked about for a parallelogram. Okay? Opposite sides are parallel, opposite angles are congruent, opposite sides are congruent, consecutive angles are supplementary, and the diagonals bisect each other. Okay? Those are all the properties of a parallelogram. And for a rectangle, we have 2 additional properties. All 4 angles are right angles. That's kind of the definition of a rectangle. But then another one is that the diagonals are congruent. Okay, so not only do the diagonals bisect each other, but in a rectangle, the diagonals are also congruent. Right? So we're going to use these properties to set up and solve some problems today. Right? We've got 2 examples dealing with, with this picture up here, quadrilateral RUTS. It says this is a rectangle, and US, which is this diagonal. Remember, a diagonal is just a line that connects non-consecutive vertices. So this is 6x plus 3, and then RT, the other diagonal, is 7x minus 2. Okay, so if we're given expressions for the diagonals in a rectangle, okay, we know that the diagonals are congruent. This is the property that we're going to use here. So I'm just going to set the 2 diagonals equal to each other. Okay, so for example 1, we'll say 6x plus 3 equals 7x minus 2. Okay, and then this is a pretty straightforward equation to solve. The x is on one side, numbers on the other. We get that x is 5. Is that my final answer? Yes, right? It just says find x. In the other example, we're given some angle measures. Okay, we're again told that this quadrilateral is a rectangle. Now we're given some angles. So it says angle STR. So STR is this angle right here. That is 8x plus 3. And then angle UTR, this angle right here, is 16x minus 9. Well, those are adjacent angles in a rectangle here. One of the big properties of a rectangle is that all 4 angles are right angles. So these 2 angles will be complementary, meaning they add to 90. So my setup here would be to add these 2 angles, 8x plus 3 plus 16x minus 9. Set that equal to 90. So combine like terms. 6. Add the 6 over. Divide by 24. What is that? 4. Is that my final answer? No. All right, this time it says find the measure of angle STR. So this time I need to plug that back in. So STR, we're given the expression here. So the measure of angle STR will be 8 times 4 plus 3. So 32, 35. Questions? Okay, so both of these examples, we used the two new properties of a rectangle. In the problems that we're going to look at here down below, we're going to give you guys some time to practice. All of these properties may be used. Right? You could be using that opposite angles are congruent, or consecutive angles are supplementary, or opposite sides are congruent. Okay? So let's take a couple of minutes here and see what you guys can do with the problems down below, all dealing with that picture that we're given there, quadrilateral ABCD. All right, here are the answers. Okay, so take a look up here at the answers.
How did you get 30? And what? The number's not.
Well, you got all the way to the x values.
I know, but I got one.
All right, we'll go through it here. Now, so I'm assuming we want to do 7 and 8, right? Are there any others before we do 7 and 8 that we want to look at? Anything in 1 through 6? All right, let's take a look at number 7 then. So we're given the measure of angle DBC. So DBC is this angle right here, is 10x, and then I'm given the measure of angle ACB. So this angle right here would be 4x squared minus 6. So the first thing we have to look at is these two angles are going to be congruent. Okay? In rectangles, all 4 of these triangles that are created by the diagonals will be isosceles, because we know the diagonals are both bisected and congruent. So that tells me these two angles will be equal to each other. So I can say 4x squared minus 6 equals 10x. Since we have a quadratic, what we want to do is get everything on one side equal to 0, and we want to keep our coefficient in front of the x squared term positive. So I'm going to subtract the 10x over to the left side here, and we'll end up with 4x squared minus 10x minus 6 equals 0. So now we need the x factor. Right? This is something you probably haven't seen for a while, right? Probably about a year since you x factor. So what we want to do is the setup is take our A times our C, which is the first term and the last term. Multiply those two together, and then just put the B term, which is the middle term, down here. So 4 times negative 6 would be negative 24, and then my B term is negative 10. So what I'm looking for now is two numbers that multiply to negative 24 and add to negative 10. Okay, so it might help if you list out the factors of 24. Right? I mean, you could just start listing them out. 1 times 24, 2 times 12, 3 times 8, 4 times 6. I think that's it. Right? So we want to try to find some combination of these that multiply to negative 24 and add to negative 10. Right? What ends up working is the 2 and the 12. Okay? It might look like the 4 and the 6 would work because 4 plus 6 is 10, but there's no way to make one of them positive and one of them negative to get them to add to negative 10. It's actually going to be the 2 and the 12. And if I make the 12 negative, 2 plus negative 12 is negative 10. 2 times negative 12 is negative 24. So what I'm going to do with this information now, I'm just going to split the negative 10x up into 2x and negative 12x. So this is going to become 4x squared plus 2x minus 12x minus 6 equals 0. Okay, so this negative 10x just kind of got split up into 2x minus 12x. There is actually.
Did you do the overviews for that? All fine.
Yes, there is another way that will work all the time, and this is the way that you guys learned, though. So that's what I'm gonna show you. So now, what we want to do is group the first 2 terms, group the last 2 terms, and take a GCF out of each pair. So if I'm looking for a GCF here between 4 and 2, well, 2 divides into both of those evenly. And then I can actually also take out an x from both terms. So what we do is we write that out front, and then we, in parentheses, write what we're left with. So when I'm taking a GCF out, that's the same thing as dividing. Right? So 4x squared divided by 2x, I would be left with 2x. And then 2x divided by 2x would just be 1. Do the same thing for the second pair. Right? I can actually take out a 6 and even a negative 6. So if I divide negative 12x by negative 6, I'd be left with 2x. Negative 6 divided by negative 6 is 1. So now, since I have the exact same thing inside the parentheses, I can factor that out of both terms. So I would have 2x plus 1 times 2x minus 6. Now I can set each of these individually equal to 0. Okay. We'll finish this up tomorrow. No homework.